back after 3 months. We're getting back into it. I think we're up to number 11. Cuisenaire, Cuisenaire rods, whatever. Party, whoa, Parity, Kropki, Killer, Sudoku. Obviously, you can see I haven't done this in a while. Also, look at new headsets, wireless, because the cats ate through the old cord. Fun. Set me back a little bit of money, but however, we're getting back into it. Rules: killer, which is, we've done this I think a few times. The cells in the cage must sum to the number in the top left. So all 4 of these numbers must add up to 23. And a partial parity Kropki. It's such a mouthful. We have these black and white diamonds. Basically, the numbers on a black diamond must both be of the same parity, being odd or even. So either they must both be even, or they must both be odd. And then the opposite is true on a white diamond. So then one has to be even, one has to be odd, or the other one has to be odd, and the other one has to be even. As you can see, oh no, yeah, cool. Those are the only rules. They will be in the description again if I do remember to do that. I'm going to use this combinations calculator because, you know, who wants to do math at the end of the day? But that obviously has to be 127. That drew my attention as soon as we got going. And I feel like our way into this puzzle is looking at evens and odds. As you, I don't know if you saw when I was loading in, I have done this before, and I got a time of 135 minutes, which is 2 hours and 15 minutes. So hopefully I beat that, but that was done like 3-4 years ago. So hopefully my brain's improved and I can actually crack it better and faster. That being said, I don't remember anything about how to solve the puzzle. So we're solving it together. What do we do? Okay, well, one of those has to be evens because you can't have 6 odds in a box. You can only have 4 evens and 5 odds. Okay. For this cell to add up to an even digit of 14, that has to be an even digit. Because if those are 2 evens, that has to be even to get to an even. Those are 2 odds, that has to be an even to get to an even. So actually we'll color code this. Color code for an even digit. Red. And I think that's the same with this 16. Oh, and this 16. Oh, and this 12. Right, so all of those have to be even digits. Okay. So these 15s, well, an odd number means 2 even digits. We get 1 there and 1 there. That's nice. Now these double diamonds, very interesting, because that's telling us that along with these 3 digits we either have 2 odds, 1 even, or 2 evens, 1 odd. Whoa. Okay. So I believe the evens have to go in the middle here, because if the evens went on the outside, let's use a hypothetical even color here, orange, and a hypothetical odd. I think we'll make odd blue, so make hypothetical odd green. Let's say we do this. We know we have 2 evens in here somewhere. Let's just say for this hypothetical there, that would be an odd. We've already got our 4 evens in the row, which means this can't contain an even, but these rules tells us that it has to. So I believe that our evens have to be in the middle here. with our odds on either side. Now that can't be a 1, so that has to be a 3, 5, 7. Whoa, not like that. A 3, 5, 7. That has to be a 4, a 2, or a 6. And that can still be anything. Oh, that even can only be 6, 8 as well. Look at that. Bang. Right, so that can't be. Those two can't be. Oh no, we use blue for guaranteed. Hot and cold type stuff. We'll use blue because let's say those were 2 evens, it would have 5 evens in the row, which is illegal. Okay. Okay, this has to be odd. Because we have 1 odd here. No, we have 2 evens in these 3. We need a third in this diamond. And these both can't be even because that would make 5 evens. Which is not allowed. Ooh, got a little bit of a... This 23 with 1 even in it, no, 1 odd in it, means we have to have 2 more odds in it. Okay. We have to have 2 more odds up here. Let's say this is our even. That'd have to be odd. Those 2 are odds. That and... Oh! Hang on a second, that just doesn't work. Because now we've got 5 plus the 1. So that has to be an odd digit. Oh, I've used the wrong color for the blue there. So that has to, we decided that can't be an even, so that's an odd, making that an even. Well, I guess we can just label these in our red. What am I doing? Red is not orange. Red is our evens. Okay, let's fiddle down this 15. We can't be 159 because we need 2 evens. And our odd can't be a 1. And we must have a 6 or an 8. Can't be 3 odds. Actually, we know that has to be a 6, 8. So we can't have all these. We can go 2, 8, 5. Let's just write in all of them. We can go 2, 8, 5. Or we can go 2, 6, 7. Or we could go 4, 8, 3. Or we could go 4, 6, 5. Cool, and that's the same over here. Okay, we've got a 3, 4, 3, 5, 7 triplet, which means that has to be a 9 because it can't go anywhere else. Our first digit makes that a 2. And that can't be a 2, so that can't be a 7. So one of these must have a 7 in it. And the one with the 7 has the 6 and the 2. Okay. Now what to do with that knowledge? No clue. Okay, what are the chances are that that's our odd out of those? Oh, sneeze incoming. Yep. A little sick. Okay. Where were we? Oh yeah, we're trying to prove that this is not an odd. Because that's 3. 1 has to go there, 1 has to go there, which means these are 2 evens. Great success. We proved 3 cells. Now this interests me, this y, because we know there has to be, these digits here will add up to an even number, because odd plus odd, odd plus even, which is an odd number, plus an odd plus an even, which is an odd number, equals an even number, and these two must also then add up to an even. Which means there's a cheeky little black diamond in here. Which means these 3 digits are all the exact same. And there has to be 1 there as well. Okay, let's run the hypothetical that these are all even. We know there has to be 1 there. Which means the rest of these digits are odd. That makes that an odd. That makes that an even. And we'll just fill these in like this. There's 4 evens in this row, which means these are all odd. Actually, we'll change from green because that is very similar. Oh, is yellow too close to orange? We'll go pink. Because green is very similar to my my pointer mouse thing. So pink is like the blue, the hypothetical blue. I know this might be so confusing. Okay. Given that it has to be 1 there, those have to now be hypothetical blue. And that, to make 22, would have to be hypothetical like that, like that, like that, like that, like that. This is all still working. And there is no reason why I see this failing so far. That has to be orange. And they have to get 2 there. But that has to be orange as well. Don't have to be a pink. These 3 would have to be pink. Those would have to be pink. Those would have to be even. Those would have to be, that has to be an odd now. That has to be pink. That has to be orange. Those now have to be pink. That now has to be pink. Those 2 now have to be pink. Those 3 now have to be even. Bang! Breaks. There's 5 even in this row. Which means that these can't be even. Okay, we're going to run that again just to make sure I am not talking shit. Except I'm going to do it more audible so you guys can understand my thought process and I can fact check it. We say there has to be a black diamond in there, which I'm pretty confident about, which means, let's say hypothetically, these are all even. Given that these are all even, this can't be even, so that has to be our odd pairing, which is pink. Makes those our even pair. Which makes that our even number. And that's our odd number now. To make this add odd. This row, we already have 4 evens, so the rest are odd. Our 4 evens like this, meaning those 2 are odd. And 22 needs an One even, one odd here, okay. Where do we go from here? Okay, we know those have to be even because we have one odd here, which means these both can't be odd, which means that's odd. We need another even here. We've now got 4 evens, which means these are all odd. Oh, not blue. Oh no. Pink. It means these two are odd. Black diamonds. And we need 4 evens in this box, so there has to be... We have 1 there, which means number 2 and 3 are there. That means that's number 4. And where do we go from here? Okay, that has to be odd now. We've already got 4 evens. Those two have to be even. Then where do we go? Where do we go from here? This is it, right? These can't both be even, because if that's even, that's 2, 3, 4, 5, and those are odd. And to make this add up to 22, that needs to be even. That needs to be odd, because you got the diamond, that's 5. Those two now have to be even. We have 4 evens in this row, making all these odd. Making that an even. This makes that an odd. We have 1, 2, 3 evens. And 1, 2, 3, 4 odds. Which is not possible here. That's a different conclusion that we came up than last time. Well, I guess those 4 make that even as well. I guess making technically having to make that odd. Having to make that even. There's 5 and whatever too many down here. So it just doesn't work. Which I think we've decided that those middle few digits must be odd. All 3 of them. Okay? That feels like we got somewhere. Okay, now those are both odd as well now. Surely that doesn't work. Giving us evens out here. And here. And odds here. Can we just prove... Oh no. Once again, same thing here. Those have to be odd now. Because we can't have 5. 2 odds means that's an even. And that's an odd. So it has to be odd in there, so those are 2 evens. Okay. This is going somewhere. Hopefully somewhere good. Okay, we've got our 4 evens down here, making all those odd. Making that odd. Making that even. Whatever this happens here, that's an even. That's an odd. They're the same here. Well, one of these have to be even. We can't have 3, so that means that is not an even. That breaks, because now we've already got 4, so these would both have to be odd, even, which would mean 5 evens. So those both can't be even. Beautiful. Slow progress, but you know, we're getting there. Which means these are even values, which means that can't be 1 no longer. That's an odd, making that an even. That has to be 6, 8 now, as well, yeah, obviously. Let's remove all the ones in here without a 6 or an 8 in them. And 3 evens also do not work here. And we can't have a 1. Okay, I feel like we just went from like 0 to hero right there. We can't have a 1 because it's already down here. It must have a 6 or an 8, which that doesn't. That doesn't. That doesn't. We only have 1 even. That has 3. That has 3. That has 1. That has 3. So this has to be a 3, 5, 6, 9. With that being our 6. Making that an 8. Making this our 3, 5, 9. And that means that is our 7. Okay. We are getting there. Kind of want to run another hypothetical where that is our even digit. Let me just mark that as our starting. Because if that's even, this same thing applies. That has to be odd. Which makes that odd. Making these even. Making that odd. Another odd there. Making that even. Making those two even. Making those two odd. Making those odd. Is that even? That odd. Which doesn't work. So we're saying that has to be our odd digit. We're going to run that again, just to be sure. This is our digit we are talking about, making it that even. 1, 2, 3, 4, 5 wouldn't work, so that's odd. That is now, if that's our even, that's our odd digit. 3, 4, 5 makes these two even. 1, 2, 3, 4 makes that odd. 1, 2, 3, 4, 5 makes that even. To make this add up to an even digit, we need either 0 or 2 in here. I think I just assumed last time those two had to be even. But I guess those two can be our even too. No, those two can't be. That'd be those two would be even. Which is scary. So it's either those two are even, or those two are even. I reckon we'll run this. This is our second what if point. Makes, because this surely breaks. Makes those odds. And this 25, right, must add up to be odd. So that's even value. That has an odd value. Means that's an even value. Makes that's an even value as well. I guess, yes, we did know this. That's if these two are evens as well. 1, 2, 3, that has to be even now. Because that has to be two odds. That means that has to be evens now. Because we've got 4 odds. So that doesn't work. So if this is even, these can't be the evens. Okay. So we're back to the case which I wrongfully predicted first. That's odd. 1, 2 makes this odd here. 1, 2, 3, 4 makes these two even. Makes that an odd digit. 1, 2, 3, 4, 5 makes that even. We've established that these two can't be even, so we need to have the evens in there. Those are now odds. Odd, even, and that doesn't work because this bottom row doesn't work now. Right, so this has to be an odd digit. Okay. Which means that's L1, and that's the red digit. I think we learned something about this 25 as well. Now this will add up to an even digit. That will add up to an odd digit. Odd number, even number. To keep this odd, these two need to be even. Which means these need to be odd. I mean, that makes so much sense. So, we'll see. And we've got a nice little T-bone here. And that has to be even now. And this is all confirmed. Like, this is locked and loaded. Like, there's no if, maybes, and buts about this. If you're not following, I feel like I'm going to be short. I'm going to spend so much time. So I'm not going to explain. That should all appear decently obvious, all this color coding right now. You just follow the cursor. It should all make somewhat a decent amount of sense. I think that has to be an even. No, that has to be an odd. Because there can only be one even up here. That means there has to be one even here. Making that an even. Because we can't have two evens here. Actually, we could. Ooh, my battery is running low. Thank God I found that. Okay, time to go find a charger. Charger plugged in. I've completely forgot what we're doing. Do have this cell highlighted though. Oh yeah, we're trying to prove something that just didn't exist. 1, 2, 3, 4. Can I do anything else with the rest of any of these? Not really. I guess that can only be a 4 and 8 actually. It can't be this 6 or this 2. A 14 with 3 even digits. 2, 4, 8. Beautiful. That if we figure out this, oh, that means that's our 6. Okay, that's our 4. That's our 8. 4 plus 5 is 9. 3 7s in our outside, okay. That means our 25 now has to have a 6 in it. Cool. And it can't have a 4 on it. You can only have 2 evens, which is 6 and a 2, a 6 and an 8, 6 and a 2. Cool. Yeah, so that this is a 2 8 pair up here. Now 22 with 4 odd digits, there should only be one combo that does that. Yep, 1579. 1579. Which means that's a 3. So we know this can't have a 6 in it now. And it can't have a 3 in it now. Okay. That does. Can I figure out 1, 2, 3, 4? That's odd. 1, 2, 3, 4, 5, 4, 5. That's even. Two, 4, 6. Okay. So obviously these have to be opposite. Actually, yeah. Which means there has to be an even in one of those two, which means these two are odd. That means that's an even. Given there has to be one even here, that now has to be even. that's 4. Those are 2 odds now. That's an odd now. 2 evens, an odd, an even. 1, 2, 3, 4, even, and odd. And we still don't know these two. Lovely. Lovely jubbler. Okay, given a 6 can't go there or there, and it means in this box the 6 has to be that one, and our 6 and our 15 means it can't be this one or this one. So it's either, okay, this is now 8 over here as well. So this is either 2, 6, 7 or 4, can't be a 5. So this is 2, 6, 7. And that works out over here as well, making that a 6 and that a 2. Our 2's down here, make that a 2. 4, 8 pair makes that a 2. 2 in this box now goes here. That's now 6. Okay, that's now a 4. That means that's now an 8. Means that's now an 8. Which means that's now a 4. That's now a 6. Okay, this has to be a 2-6 pairing now, which means this is a 4-8 pairing. Oh no, it doesn't. This has to be 2-6, that has to be 2-4, meaning this is not a 4-8 pair. But this is a 4-8 pair with that. Which means a 6 has to go there now. Which means that is a 4-8 pairing with that, and that, and that, and that. And the 6 can't go there, or can go there actually. Literally says it can go there. And we know that whichever one, the 2 would have to be there, and the 6 would have to be up there. Okay, this 25 now has a 2 in it, so we know it has to have a 2 and a 6, which means it's this 25. Oh no, that also had a 25. Was it that one? A 2, a 6 with 3 digits? Yes. So we know it has a 9 in it. Which doesn't really help us. It either has 1, 7 and 9 as the odds, or 2, 5 and 9 as the odds. Okay. This must have a 6 in it as well, actually. We'll do that first. Okay, and it can't have a 2 in it. And you can only have 2 evens, which all of these do. Which is good. So we have 2 options for this one, and 3 options for this. A 16 with a 2. Okay, there we go, a 5, 9. Which means that can't be a 5, 9. Which means that has to be a 1 or a 7. So now this one has to have a 1 or a 7. Which means it's that. 1, 2, and 7. like that. Which means this, no, not 1, 2, 1, 7, 9. A 12 with the 6, okay. So this one has to have a 6 in it. There's only 2 that do that, and one's 3 evens. This is 1, 5. A 16 with either a 4 and 8. That's more difficult. Okay, that can't be the one. Okay, that can't be a 1. A 7 has to go there. Okay. We know the 3 has to go there. 1, 3, 7 is our combo down here. Making that a 3, actually. Because 3 can't go anywhere else in the row. Ooh, this would be a 1, 3, 7. It has to have 2 of the digits 1, 3, and 7, which means it cannot be this. So it either has 4, 8 or 4, 6 with 7, 5, 3. Would go 5 and 3 and 7, or it would go 1, 3 and 7 in any combo. Does that have to be a 1 or a 7? Not really helping. Okay, 1, 7, 9, 5, which means a 3 has to go in one of those two. Like that. Nope. This 16 has to have either a 4 or an 8 with 2 odds. Can't have 5 and 9. Which, sure. Okay, well that has a 7 up there. Okay, whatever that goes there as well. Okay. If only I could get this, that would help us out so much. And I probably could get it, but I'm probably being stupid. That has to be a 5. Okay. Which I should have found a little bit ago as well. Okay, let's figure out this 28. It has to have both and only a 6 and a 2 out of the even numbers, which means that's not it. That could be. That's not it. No, that's got 4 even. 6 and a 2. Which means it's not that, and that's got 4 evens. So we know this is our 1, 2, 3, 6, 7, 9. Cool. So let me just write, so the 2's can only go there, the 6's can only go there, the 1's can only go there, The 3 can only go there. 6 we put in, the 7 can only go there. And the 9 can go anywhere. Cool. That's how that one works. And we still don't know which one's odd and which one's even. Okay, well we've got 1, 3, 7 and 9 in there, so that means 5 has to be out of there. And the next step. One 5 up there. Okay, we know that that has to be a 1 9 now. Can't be 1 6 9. Okay. There's no killer cages that give us any hints now that it does there. This is just basic Sudoku, and I am failing. I mean, that can't be the 7, that has to be a 1 9 or 3. That has to be a 1 or a 9 or a 3. If that is a 3, that means the 3 has to go in here. It doesn't help us. Okay, that can't be 1 7. Because then 9 has to go there. Which means if it is this top one, a 1 or 7 has to go there. Which means a 7 couldn't go there. No, that doesn't work like that. Okay, well the 1 has to go there, so that has to be the 9. It just took me a while to get there, but you know, we got there. This has to be a 3 9. That's obviously a 3 9 now as well. Okay, this row, the 9 3 can't go, that means that's the 5. Three nine, 3 9. 3 9, 3 9. Which means that has to be the 5 as well. Which means this is a 7 1. Which is dangerous, which means this has to be a 1 3 7 as well, which means this has to be this one. 1 3 7 6 and 8. Bang. Okay, we should be able to fill in all the evens now. And this puzzle should fall like an old lady trying to get downstairs. Whee, that's a 4. Which means this is our 8. Okay, and somehow that's whittled down to just a 7. So we'll claim it. That being our evens now. Making that a 2, making that a 6. Okay, sick again. I'll be back. I feel like we're there. Okay, let's continue this. I don't know what that was. What am I thinking? Yeah, okay, that makes a 9 there. I agree. A 5 can definitely go there. Okay, that's because I accidentally typed a 5 in there. That's why that removed that. And that can also still be a 5. Yes. Which means that can't be a 5 actually. Which means that is the 5. That's because we accidentally typed a 5 in there. That's why our things got messed up. That can't be a 7 now. And that a 1. Let's make that a 7. 1, 3 there. Means that's the 7. Also, you know numbers can't repeat within a cage. That is another rule of those, by the way. I failed to mention. But most of you should know it. Okay, this can't have a 1 in it, and it has to have an 8. So this is a 3, 5. Making that a 9. Making that the 5. This now has to be our 1, 9 pairing. Which doesn't break immediately. Okay. That can't be a 9. Well, it does, I just couldn't see. Makes that a 5, makes that a 1, makes that a 3, makes that a 5. It's the only place a 1 can go in the box. Which means that has to be our 7, making that our 3, that our 9, that our 9, that our 3. Okay, please be right. If I did 1, 5, 7, 3. Bang! That's such a good time. I'm pretty happy with that. An hour though. Oh, scary. I don't know when this will go out, but hopefully soon. And then hopefully I can do this Sandwich. Sounds very German, but that looks fun. Mix of the X's, the V's, and sandwich clues. And I like sandwich clues. Yeah, that's it. Hope this was helpful. Remember to turn those notifications on for those occasional times that I post a video. Cheers.